Good morning and welcome back to Section 11 News, where we discuss all things biology. Thanks, Caroline, for that amazing weather report. I just received news that we get to interview two distinguished gentlemen of a special phylum called Kinorhyncha. Let's go there now. Let's check in with you, Dr. Willett. Hey, Dr. Willett here. Thanks for that great introduction. I'm in lab here with Kyle and Keith, the Kinorhynchas, who will be discussing a variety of things. So let's get started. So, start me off with who you are and where you're from.
What's up? I'm Kyle. I'm part of a clade of marine meiofauna. If you're wondering why I look so good, it's because my body is made up of retractable introvert bearing rings and cuticular spines and a limbless trunk. I also have distinct segmentation of my nervous, muscular, and epidermal organ systems. I'm originally from off the coast of Japan, but I like to spend most of my time in the mud, sand, and deep sea sediment. Sounds weird, but that's just what I like, man.
Awesome! As you know, Thanksgiving was recently. Did you celebrate with any relatives?
Well, I actually have a pretty large family, 338 cousins and counting. The three main family branches are the Loriciferan family, the Priapud family, and the Kinorhyncha. Members of these families can be split up and classified by number of placids, shape and length of the dorsal spine, and presence of the dorsal spine. As for my friends, my only friend that I made was in 1841, a brilliant man and naturalist by the name of Felix Duhardie. He made our family's existence known and to the world just a couple years later. And don't even get me started on a girlfriend. Our kind don't really do that kind of thing. We like to stay single and separate.
Let's go to you, Keith. What do you enjoy eating and what do you do in your free time?
Yo, I'm Keith. Thanks for having me. Bacteria and tiny microscopic organisms living on the surfaces of grains of sand are my favorite.
Yummy!
So tasty. Many of the organisms I consume have a shell around them, so I collect them with my tiny bristles and I use them as tweezers to pinch the end of their shell. This squeezes out the organism right in my mouth for me to eat it. As for my free time, I like to go to the gym and move around, obviously. My favorite workout is facilitated by alternative action of dorsal ventral muscles and head and mouth cone retractor muscles. Here, let me show you me and my pal Kyle walking to school. I hope we got to school on time, man. Dude, school started 4 hours ago. Oh. Come on!
So, Keith, what was your childhood like?
It's pretty wild, honestly. I first started out as an unfertilized egg, and then I was later deposited into an egg case where I was fertilized. As an embryo, I instantly developed into my juvenile stage with 11 of my 13 body segments formed. I just wanted to be a teenager really bad. Then, after 6 molts, which is the process of shedding all my skin off, which I usually do at the gym, I then have all 13 of my body segments fully formed, making me the nice adult that I am today.
Puberty hit him hard. Thanks so much for that astounding interview, Kyle and Keith. Let's talk about some phylogenetic trees. When looking at the tree created from RNA data sequences, we observe that Kinorhyncha are most closely related to the phylas Arthropoda and Mollusca. When looking at physical characteristics, our phylum is most closely related to Annelida, as the two phyla share multiple of the same characteristics. For example, mobility, bilateral symmetry, and a two-opening digestive system. Both of these created trees have Porifera as the outgroup, as we consider that to be one of the most simple phyla. Our two trees differ quite substantially depending on if we are looking at RNA data or characteristics. The main difference in taxa groupings is the placement of chordata, as we expected it to be more closely related to Arthropoda and Mollusca rather than Echinodermata. The final tree that was pulled from a primary article shows that Kinorhyncha is most closely related to Mollusca and Arthropoda, which aligns exactly with our RNA sequence-based tree. That concludes our segment, ladies and gentlemen. Thanks so much for joining us. We'll be back right after this quick break.